Okay, let me switch to where's the leave, continue here. Okay. I'm switching between two PCs, so it's at the moment it's messy. Okay, so let's start. So I hopefully everybody got the email I've sent like an hour or so ago with information what you need to participate. Okay, there's a link there to a Google Drive here. That's what's out there. And I would suggest that you get those two files, day one, day two, and put them in either on your desktop or in a folder somewhere that you'll be able to find those. So those are two files that will go today and tomorrow. And we'll go through them using Spider, which is environment used for writing programs, running programs, debugging, and whatever. The convenient way to install it is to go to Anaconda here, and then if you follow to download, you're gonna end up with installers depending on what computer you're using. You should either run the Windows installer or Mac OS or Linux. And once you've got those got it installed on your desktop, you should end up with Anaconda Navigator down somewhere here. Once you click, it should start. Come on. And we're interested in running Spider. So just launch Spider. You might get a message that there's a newer version available there or whatever. As long as you're running something relatively recent, any Spider 4 point something is fine. As long as you're running Python 3.7, 3.8, you're fine. So there's no reason to worry about being a little bit obsolete. We're not doing anything that requires completely new, completely up to date code. Okay, once you start Spider, let's get rid of this thing. You're gonna see something like this, and you need to open the day one file, which I did place on my desktop in a directory called intro to Py here. Come on, and that's the file that we're gonna work with. Okay, so your Spider might look a little bit different. I did a few modifications. I made the font bigger. I changed the colors to something more reasonable default. A lot of setup for Spider is done going through tools, preferences. I just changed appearance, changed the theme, and made font bigger so it's easier on your eyes. So that's basically what are differences you see. Otherwise, what you see is a window with three panels. The major part is a text editor. This is just editor for editing, for writing your programs and looking what's there. So this is this biggest part of the Spider. Then on the right side there are two panels. The one at the bottom called console or something like that will show up the result of running the program. It will you will see there whatever the program is printing out or whatever errors are generated. So So this is how you see what happens when your program is running. And then at the top, there is a panel with several tabs. The useful one is this variable explorer, which shows you the state of the program when it's running. Let's say it like that for a moment. And also there's a help panel which can be used for getting some information about different elements, different objects in your code. So this is useful when you want to learn what the proper syntax is. Okay, now what Python is? Python is a programming language. It's essentially a specification of syntax and grammar of a language that's used to describe what the computer is supposed to do. It's essentially a way of writing a recipe for a computer to perform whatever tasks you want it to do. And that's just the specification. What Spider is a combination of a text editor which allows you to write files to be run as a Python code, and a Python interpreter, which is a program which takes as input a file with the Python code and then runs it and shows what the result is. So that's what is Spider. And let's start to go through the file. So in our case, the entire file is separated into so-called cells. They are created by using hash %%. Then we've got now a cell here which contains nothing. It's just empty. We can run the contents of the cell as a snippet of Python code by pressing Shift and Enter on Windows. And you see there's extra stuff showing up here in the console. It's the result of running the program. In our case, it's very, very boring because this is a program which does nothing. There's nothing there to run. So the output from the program is just nothing. Okay. We can put comments into the code, and this is reasonable if the program starts to be bigger, because then it helps to explain to whoever is reading it, and it's not always you. It might be some other person willing to use your program. So it's reasonable to comment your code to let others know what this thing does. And to make comments, we just use a hash or $sign and then we can put a comment. So here's another cell. It starts as the one above with hash %%. And then we've got now a cell with just comment. When you run it, we can do Shift, Enter. And once more, this program does nothing. It is composed of one line with a command. So there's nothing in the output, so it's boring, but now we've got a cell with a command there. So that's the mechanics behind running snippets of code in Spider. So that's what we've got somewhere here. Now, programs that do nothing are in general boring because there's nothing happening there. So we should start writing something that actually generates output. So let's make a simplest possible program which is gonna print something to the console. So to print something in Python, we just type print, and then we can put into let's say double quotes something we want to print. So let's get the standard simplest program, which is gonna say hello world. Okay, so here's a simplest possible program. There's equivalent in every possible language in the universe that does the same thing, prints hello world. And now when you run it by pressing Shift Enter, now we do have the program copied to the console, and then here's the output from the program. So that's what you should see. If the console becomes pretty clumsy with a lot of stuff showing up there, you can right click and clear console, and then it's gonna get back and it's gonna be cleaned up so it is more readable. And then we can go back to our program and run it once more. Let's do Shift Enter, and here's once more the copy of the program code and then the output that the program generated. So this is the simplest possible thing we can do, but it's still boring because we're just printing out pre-made piece of text. To be able to manipulate data, we've got to be able to store data in so-called variables, and then somehow manipulate them, modify them, combine them, and then print out something, print out the result of those operations. And we're gonna go on for 3 days through different ways of creating different types of data and modifying it and then processing it and then printing it out. Data is stored in so-called variables. To store something in a variable, first we've got to come up with a name. So let's create a variable called, let's say, my string, for example. This is a name of a variable. You can think about it as a pigeonhole that the data is going to be stored in. So this is something which we will be able later on refer to if we want to access the data stored there. To store data in my string variable, we're gonna perform so-called assignment operation, which looks like this. Let's say we want to put into my string our hello world string. So what this line means is take a string hello world and put it into variable with the name my string. So assignments are conveniently read from the right side. You take whatever is on the right side of the equal sign. This is our piece of string, and we're putting it into a my string variable. Okay, so that's all that this line does. And now we can print the contents of my string variable by typing print my string. Okay, and let's run it. And once more, we do have a piece of the code printed out, and here's the result of our print statement. The difference between whatever we had here is that in the first case, we were printing directly the string, so that's why there are those double quotes. They let Python interpreter know that hello world is a string that we want to print, versus the second variant of the print statement takes my string variable, and the Python interpreter is gonna look what's in my string variable sitting. So this is what happened line above. We put hello world string into the variable, and now the print statement is spitting it out on the screen. If we put double quotes around my string like this, then this statement is gonna print out my string, because now Python is told that, okay, take a string, my string, and print it. So here's what we're gonna get. So we can pass more than one variable or a constant or a string to a print statement. So we can say my string, and now the difference is the first argument to the print function is called is a string with a piece of text. The second one is variable that we initialized to hello world. So now if we run this thing, we're gonna get my string coming from the first argument, and then hello world coming from the second argument, which is a variable containing hello world. So, oh, there's a chat something. Let's see. There's a bunch of stuff on the chat. Let's see what's there. Okay. Okay, so let's see what are the questions. Let me look at those. Okay, so starting from the beginning, I didn't get someone. Austin during. Thanks from today, Kite. No, good assistance, not. Thank you. Okay. Okay, so as far as comments not showing up in the console, it might be some modification that I made to the setup of the spider. I think there's a way to make it show those or not. So this might be some difference in a preferences. Let's see what it could be. Interface. Interpreter default is shown, no. Completion, execute, directory, interact. Let's see, completion. I'll fish it out and get you an answer to the comments in a console later on or tomorrow. I know it's somewhere there. You can set it up. So that's those are the comments. Okay, Python is not using semicolons. Every line is on its own. There's no semicolons there. There's no curly brackets like in C, C++. Python is very sensitive to indentation. So in this particular case, every time we've got the line, it starts in the first column. If we add a space here, for example, then we're gonna run into trouble. Let's try it. You see, there's gonna be indentation error. So Python is very sensitive to how to the position of the statements within the line, but it does not use semicolons to separate lines. So this is peculiarity of Python. You're gonna see more of that when we go into more complicated statements with loops or if statements that indentation does have meaning. So okay, is good. Next, scene without running on. Is there a space? My string. Yes, when there's more than one argument pass to print, then default way is to have a one space character as a separator. You can convince yourself to it by trying to do something like this. For example, if we print now 3 arguments, now when we try it, you see that we printed my string and a colon for the first argument. Now there's a 1 character space, and then there's another column coming after it, and then there's another space, and then contents of my string. So this is default way the print statement works. Print is pretty complicated. There's a lot of options, a lot of things to set it up. To get information how print goes, what you can do is you can click on the help tab and then go to print and then do Control I, and you're gonna get information about print, at least some basic information about how print statement works and what are the options it takes. If you're looking for more, there's extensive documentation that you can find. Let's do Python org, and then you can go to language reference, and there should be somewhere. Let's see. There should be somewhere. Let's see. In quick search, print. Can go to print. Let's see where to find it. No, that's not a good idea. Let's go back. Library, it's gonna be under library reference, I think. Text processing, building data, numeric, file, data, file formats, concurrent. Let's try print. Doesn't work. Let's try like this. No, there should be somewhere. Where is it? No. Search. Let's try somewhere here. Print. No. Well, what about the simplest thing? Python print starting print Python print statement print statement. Let's try here. And here we've got it, and there's gonna be print, string, print. There should be a way. Well, there's, let's try. Python print, no. I'm trying to find the actual, okay, here we go. So here, with a little bit of patience and clicking, you'll be able to find things. And here's what I was looking for with actual description of what print does. So the website for the Python is your help. There's quite extensive documentation with a lot of information what can be done. Okay, let's go back to our our file. Okay, so this is how we print either strings or variables. Now, one thing about variables is that not all the names are allowed. So in general, they should start with either a letter, either a lowercase or an uppercase. Okay, A and B. Case matters, so those two variables are different. We can convince ourselves that they are different by just printing them. We can do print A and A. That's A str, and here A str. And if we print those here, I'm gonna once more clear the console and run the snippet, and our print statement printed up contents of variable A, that's here, and then contents of variable capital A, and that's what's here. So those two variables are different. So Python is case sensitive. The names may contain numbers, so we can now use A1 and A2 as the name of variables and print them, but numbers cannot be in front in a first position. So this thing is not gonna be, this is not gonna be valid. Here, we're generating syntax error. The reason is the names of variables cannot start with numbers. Otherwise, characters other than letters are allowed. So we can have a name starting with underlines. That's perfectly fine. So something like this is valid. It's except I'm pressing wrong things, so I'm getting extra stuff. So let's run this thing. Underline A2 is not defined. Well, because I've got one here. So this is very common that you're writing your program and then something doesn't work. You're gonna see an error message telling you something about the problem with the program. The one we had here is a syntax error, invalid syntax. Sometimes it's cryptic. With time, with experience, you're gonna be able to decipher those things in more rapid fashion. Here it's syntax error because the variable starts with one, which is not allowed. Here we've got the name error because I was trying to print out contents of variable called underline A2, but I didn't have it defined. I had only underline 1A2. So that's why the name error came into play. So now I corrected, I removed this extra one here, which was unintentional. And now when I run it, I'm fine. If I want to clean the console, I can once more clear the console and rerun this code once more. And we do have the variables printed out. So there's no limit on how long the variable is. There's no variable name is, there's nothing. The restrictions are relatively few, but one thing to remember is variables cannot start with numbers. So we've already printed something there. Now, what we can put into variables? So far, we had only strings. We are putting a piece of text, let's say ASTR, into this guy, or ASTR with capital A into that one. So this is one one type of variables that we can store as data. Another type, which is much simpler, is just the logical value of true or false. Variables that store true or false are called Booleans, or logical variables, and we can create them by just assigning true or false value to a variable. So let's make ourselves my bool, and let's make it true. So now we've got the value true stored in our variable here, and we can print it, my bool. Okay, and what comes out is the value that was stored there. Cell assign, this is our before. Is there a way to run cell? Let's see. Okay, let's look here, preferences. Okay, the way to find out, okay, so let's do it this way. Okay, so let me reset to default 0. Most likely do have default settings for the spider. So let me go to defaults. Okay, spider, yes. Do you want to save? Yes. Okay, and I should restart spider with default settings. Let's see where is it. Here it is. Okay, check no. Okay, install, dismiss. Okay, so this is default, and let me run it as a window. Okay, here. Okay, so that's how most likely your spider looks like. So let's go and let's open back my desktop and intro and day one. Okay, so here's my file. I'm gonna go to tools, preferences. I'm gonna switch to appearance, and I'm gonna get this guy, and I'm gonna make font a little bit bigger. Let's make it 12. Okay, and apply. Okay, come on. Okay, so here is, and now let's see what happens when I run it. Okay. Oh yeah, so you've got now this run cell, whatever mice. Okay, so now let's see how to get rid of it. So let's go to tools, preferences, and let's see in here, use following, enable, show, reload it. Let's see what's in run, execute current, remove directory, always run. I normally click this thing on. Okay, this is not gonna change anything. Now let's see. Interface, configure normal, automated. Here, advanced language, use single show internal errors. No, show nothing. Appearance. We already went through this. Python interpreter. Default, enable Okay, doesn't matter. Run. Always show directory. This looks okay. Current editor IPython console. Okay. Show. Ask for confirmation. Decode buffer. Nothing here. Nothing. Activate support. No. Settings. Gender green, the auto call, symbolic height. When no. History files. Well, I don't know how to get rid of it. Well, we'll live with this thing for a moment. Being I'll get rid of one thing which is annoying here. I'm gonna get rid of the where is it? Editor. Gonna get rid of this guy. Show top source. Oh, maybe here. Let's see. Save, maintain, copy to the console running. Save a copy. Let's see. Run a code. I think I might have this one set. Let's do apply and see what happens now. Yeah, so that's okay. So what I do have set up is in preferences in editor. I went to run code and check the copy full cell contents to the console when running. So this by default is off when I go here. Then I did okay. And now I think, let's see, clear console and let's run it. Yeah, so that's what's going on. So this was the option. Okay, so that's how to get rid of the run cell. Okay, with Python is where did I go? Python is case sensitive, so capital true is actual Boolean variable, lowercase is not. So this is peculiarity of Python. This is gonna generate an error most likely, because true with the lowercase t is interpreted as a name of the variable, and we didn't set it up, so that's why the error. So the Boolean true value is actually capitalized, and the same thing with false. Another bool is false. So now my bool, another bool, and I'm gonna give it the name here. So now this is gonna print out true and false. So this is something to remember, that that Boolean values are capitalized. The editor in Spider lets you know it highlights true and false in blue, so that it's recognized as a Python construct. If you go with the lowercase, then this stays gray, which means it's not a built-in word, not a standard word in a Python. So Booleans are colored. Okay, so now that's the probably simplest variable type. We'll get back to Booleans later on, but here, just for the sake of going through data types, we had strings. Now we've got Booleans, and then we do have numbers. with numbers, there are different flavors. There are integers, so we can have my int equals to, let's say, 42, okay, and we can print it, my int, and here's our 42, which is an integer, printed out. Now, there's no size limit, no magnitude limit on integers, so we can have something really large, and Python, at least Python 3 will take it. So if we print it out, Python can deal with arbitrarily large or arbitrarily small integers. For that matter, integers can go in the opposite direction, so they can be negative. So there's no limit on the magnitude of integers. This is different than other languages. In most of the cases, different languages do have limits on how large integers are. Python is in this respect quite forgiving. Integers don't deal with decimal places and fractions. So to deal with floating point numbers, we've got to use different variable type, which is a floating point. So let's get the variable which is gonna be a floating point, my float, and let's make it 42.2. The magnitude of my float is the same as the 42 integer here, but those are two different data types. We can print my float, and we do get decimal point. This is not integer. This is 42 with no fractional part, but it's different type. To persuade yourself that those are all different types of variables, we can check what it is. To check what's the type of variable, we can just print right type and a variable name. So let's say my float, and let's see what happens. Well, we got float printed out in the console, which denotes that my float variable is of a floating point type. As you notice, I didn't print it out. I just got a statement on its own as a last executable statement in a program, and this is what I see here. This is what Spider is gonna print out, the value of whatever this statement is. I can print it if I want to print. The output's gonna be a little bit different. Okay, I'm gonna get more verbose information that the type or class of this variable is a floating point. The advantage of print statement is that I can print many of those values in a series. I can print now my int, and I can also print type my bool. Okay, and those three lines of code will generate one line of output each. So if we print it, run it now, we'll see the output from the first print statement specifying what was the type of my float, then another line with my int, my bool. If I skip the print statement and have a series of statements like this, and I try to run it, I'm gonna get first syntax error. Here's another case of a typo. I've got unmatched parentheses. Yes, there is unmatched bracket here, another one here, another one here. So I fixed it. Now when I run it, I do see only the last value here printed out. So those statements do not generate output. Only the last one is printing things out. So it is useful for debugging. It's useful for checking things on the fly. So we can let's say my float. We can just refer to my float variable as a last statement in a script, and this is gonna print out the value that's sitting in my float. But it's of limited use otherwise, because this is not something that's gonna be printed out by a regular program. So it's more of a debugging feature. To print things out in a more convenient way, where you can print out more things, you've got to print. You've got to use print statement, and then we're getting 42 printed out as a number. So this is the simplest possible floating point. The scientific notation also works. So we can my float 1. We can have something like 42 0 e minus 10 with the minus. So this thing, and we can print my float 1. So we can use scientific notation. The output is gonna be modified in a way. So the value that we set here as 42 times 10 to minus 10th is gonna be actually printed out in a standard way with just one digit and then decimal part following it. So the print statement is modifying floating points according to some default rules. The format can be modified by specifying how to do it. I'm not gonna go over this thing. Sorry, not noxious student that keeps trying to, but with C we're taught to use doubles. With Python there's no doubles and floats. Python there's only one floating point type, which corresponds to double essentially, but otherwise it's oblivious of types. So types in Python are simplified compared to C or C++. So okay, did print out number? Just print. How did you print out the number? Oh, okay. So there's a series of conversations on the chat. Okay, so we're at printing out floating points. Okay, and we went over finding out what the type of a variable is. So far we went through strings, booleans, integers, and floating points. Okay, here's the comment about whatever I did above when printing out things like here without actually printing them out. Okay, now we've got the floats versus integers. I already mentioned that integers can be very, very big. There's no intrinsic limit on how on the magnitude. This is also different than most of the conventional languages. There's a range of integers, and there are different types in C, C++, and so forth. And you can go from small integers to longs and so forth. With Python, integers go up to whatever you want. So this is simplified compared to other languages. With floats, it's once more. Floats are formally double, so they do have a limit, but it's relatively large. So let's see what happens with our floating point that goes to 10 to 1000 or so. Let's see what happens here. Well, it is fine. So the exponent can go quite far, apparently. The problem is that there might be a limit on the accuracy. Let's see what happens here. Okay, still nothing. It's still fine. So the value is fine. There's relatively there's not that many restrictions on the values. The restrictions come into play when you're trying to make operations on numbers. So it's fine that we've got a very high accuracy for our big float. The problem is, can we add two numbers with the same accuracy as here? And this is less. This is actually not possible. If we try here, we're adding 1 and 1 times 10 to minus 30th. Let's see what happens here. Okay, we can clear console and see what happens. See, we added 1 and 1 to times 10 to minus 30th, and nothing happened. Okay, there's a limit on what's the accuracy of the addition operation. So the practical limits on the floating points are not because you can't store accurate numbers, it's because you can't perform operations on them with the required accuracy. We can try to see how what those limits are. So let's try to make a series of additions. Copy. Let's make it A and B and C and D. Let's print A and B and C and D. So here we've got 4 numbers, and let's try our minus 30th. Let's try minus 16th, minus 15th, minus 14th, and let's see what happens here. Okay, and what we see is that the first addition did nothing, so the difference in magnitude between 1 and 10 to minus 30th is too large. The result of addition is 1, so we lost accuracy. If we made the second argument to addition bigger, so now it's 10 to minus 16th, it's still missing, so accuracy is lost. We've got to go below 10 to minus 16th to get some to get the accurate result. So The practical limit is about 10 to minus 16th in terms of difference in magnitudes of things that we add. So this is what enforcing the accuracy of using floating points. So this is something to be aware. You might think that you've got a very large numbers with very high accuracy entered as your data, but then you might lose accuracy because operations that you perform on those numbers is going to be affected by the accuracy of additions or division and so forth. So
I see. Thank you. But these limits don't apply to integers at all?
to integers, no. Integers are you can add big things or small things. It's integers are fine.
Okay. Thank
So
you.
there's no fixed fixed limit on the size of integers. We can try to convince ourselves that's the case. So let's try to, let's say, print our begin +1 and see what happens. As you can see, we can add a very big number and a very small number. As long as there are integers, the difference is there. So there's no problem with integers. The problem is with floating points. So as you can see, Python is very convenient. It's interpreted language, so it's very easy to test, to try what would happen. So if in doubt, you can always come up with a test case and write a tiny snippet of code in Spider and see how things. I don't know. Did I block? It should. I don't know. Restart. I would suggest restarting Spider. I don't know why it doesn't work. It should. What happens if you clear console and then maybe it's gonna unblock things? Oh, I don't know. If nothing works, I would. This is Mariana having problems with Shift Enter stopped working. If nothing happens, I would shut down Spider and start it once more. You should be able to revert back to something something workable. Okay, so here's the reason why there's a limit on accuracy of floating points. It's not the value that you store them. The limit is that operations are performed only to certain level of accuracy. So that's something to remember about floating points. In most of the real life situations, the numerical accuracy is not the limitation. If there's a limit, there's an entire set of ways of handling computations with where accuracy of operations is coming into play. This is separate from Python itself. It's if you run into problems like that, then it's a separate issue from writing programs. Then it is specific to a given problem. Okay, so far we've got strings, we've got Booleans, we've got integers, we've got floating points. What can we do with those? Well, with numbers we can do most of the common math stuff. So we can let's make ourselves a number. Let's make ourselves a 2 point, and let's make ourselves b 3 0. Okay. One more convenient thing about Spider: when you click in the upper tab on a variable explorer, you're gonna see a list of variables that you defined when running those snippets of codes. We can clean it by right-clicking in a console and removing all variables. Yes, don't show it, and yes. And now our variable explorer shows there's nothing here. The moment we run a block of code, let's say the one here, when we run it, there's copy of the code spit out in a console, but there's no output otherwise. What changed is now we do have those A and B variables created by running the snippet of code, and the variable explorer gives us a list of variables that were created until a given moment of time. It gives us information about the type. It tells us what's the size. In this case, it's 1 because in both A and B there's only one value stored. So that's why the size is 1. The size is gonna start changing tomorrow when we'll go into lists and other types of variables. And then finally we've got the value. So this is convenient to check what's available at a given moment of time. It's convenient for debugging. We can check what are different values of variables without having to print them out when running a script. Okay, so now what we can do with the numbers? Well, we can add them. We can add A plus B. That's right, and we're gonna get output 5. This is once more following the convention that last statement that's executed, its value is gonna be printed out without using print statement. If we want to print, we can always do print, rerun the code, and here's the output from our print statement. Apart from adding, we can subtract. So we can, let's say B minus A, and now we've got the result. Why it doesn't print? Let's see. It's another problem with preferences. That's my guess. Do you have copy full set here? This is one thing to check. This is one that I modified. Now with interpreter default, I didn't change anything here. In run, I did execute in current console and interact. So I've got those two things. And then what did I change? And then I did change keyboard interpreter. No, there was one place. Python display shown, display as graphics advanced. No, where was it? Okay, general advanced views, didn't change anything here. Appearance, no.
I think it's an editor.
It's in editor. Let's see, run code. Well, copy. So I changed this one here.
for me to be able to see the same thing you're seeing. So
I know that I started from defaults and I modified run code to copy full cell. Well, we can turn it off, apply. Okay, and let's see. We want this. Yeah, so that's that's what you need. Okay, so let's clear console and once more. So if the in editor run code and copy full cell contents is not checked, when we run something, the last statement is not printed out. If we check it and apply, now if we run it, now we do see it. So this is the setting, editor run code, the last checkbox it's got to be on. Okay, good. So one problem less. Okay, if you notice here, we do run just b minus a as a statement. We didn't specify what the value of b or a is, but the code is still running fine. The reason is I ran before that the cell above. So a and b were defined when I was running the cell here, and that's why I've got a and b. If I do have a fancy to use a C in a subtraction, now I do have a name error because C is not on the list of variables created beforehand. So that's what's got to be, what you've got to pay attention when running code in a cells, that sometimes it looks like a code like print b minus a looks fine, but if you clear all variables, now it's not gonna run anymore because neither b or a is defined. There's nothing showing up in Variable Explorer and you're getting name error. Name b is not defined. And the program crashed even before checking what's in A. To make this thing runnable, we've got to make A equals, let's say, 1, B equals 2, and now we're gonna be fine. So that's something to pay attention when running snippets of code in a spider. Sometimes you think the snippet is correct, but then you realize that some values that the code is using were defined in some other cell, and the cell contents of a cell will not run on its own. So far we had addition, we had subtraction, we can multiply things, so we can multiply A times B, which is boring because we've got 1 there. So let's run this guy and now run that guy. So now we've got something multiplied. We can raise a number to an exponent, so we can, obviously we can multiply two variables, we can multiply by a number. So we can obviously say something like 2.45, and then here's the result of multiplication of 3 numbers. So math can be done either on variables or on constants, hardwired in the code as a number. Same thing with multiplication. We can raise a number to exponent, so we can say something like 2 to the power of 4, for example. So this is gonna be 16. The exponent can be a fractional. So if we want to get a square root, we can just raise 2 to 1/2. and here's our here's our square root of 2. This is different from other languages which might not allow you to use fractions as exponents. We can use negatives to get inverse, so we can say something like this. Okay, and then we're gonna get 1 over square root of 2. So here's another case. I did put brackets because I'm not sure if the order of operations is fine, but we can always check. And the result is the same. So apparently, the order of execution of this expression is first. This is used as a so this is negative 0.5 used as an exponent to raised 2. Okay, it's not like this is a argument. It's not like those are 2 arguments to a subtraction, which might be interpreted, but it's not. So in general, the preferences are the same as in conventional math notation. So if we write something like 2 times 2 plus 3 times 3, the multiplication is going to be performed first, and then addition. So this is going to be 4 and 9. So it should be 13, presumably. Yes, it is. If we want to change the order of operations, then we've got to use brackets. So then here it means multiply 2 by 5 by 3, and that's how it goes. So thing to remember about the exponents is that we can say something like 2 to the power of negative 0.5, and this is perfectly valid. So I can comment this thing out, and here's our inverse of square root of 2. Okay, so far it's pretty conventional. With divisions, there are 2 flavors. If you use just the regular slash, so if you do A divided by B, this is gonna be a floating point operation. So the result is gonna be a floating point. So 1/2 of 41 is 20.5. So this is the meaning of a slash as a division sign. It doesn't matter what's the type of the arguments. For division, integers are interpreted as floats. So the slash is implying that the division is done in floating point domain. If you want to perform an integer division, then so let's print A divided by B. For integer divisions, you use double slash, so it's gonna be A divided by B. And now if you look at the difference, you see that we're losing the decimal part. This is operation which checks how many times 2 fits inside 41, so 20 times, and then there's 1 as a reminder, but the result is integer 20. Okay, to get the reminder, we can use modulo operation, which is gonna be a percent sign and B. This is gonna now tell us what's the reminder from dividing 41 by 2, and it should be 1, because this is because 41 is 20 times 2 plus 1. So integer division is giving us 20, and remainder modulo gives us 1. So we can operate within integers, and we can get both integer division and remainder using standard operations. Obviously, as you've already seen before, the operations can be combined. So we can say something like a plus b plus b squared plus a plus b third. So we can type whatever expression we wish. Okay, we can stick both variable names and constants in an expression, and we can assign the result of an expression to another variable, so we can make C set to whatever the result of this expression is, and then we can print C. Okay, so here's the value of C printed out. Thing to remember is that this is not an equation in a sense of a math. This is not equation saying that C equals A plus B plus and so forth. A series of statements like that, let's say C equals 3, and then A equals 7. This is not a system of equations. This is a series of assignments. The first one is calculating whatever is the value of the expression on the right side of equal sign, and this value is put into C. And then in a second line, we've got 3 assigned to C. So the value that was initially used to set the C is erased, and 3 goes in place of that. And then we put 7 into A. So this is a series of assignments. This is not a system of equations. So this is something to remember. It also implies that the syntax like this, like A plus B equals 7, is not valid. This is going to generate an error, syntax error. This is because what we've got on the left side of assignment statement, it's always got to be a variable. We've got to have something on the right side which can be evaluated to a value. So 7 is our value that's constant. Here we've got a value calculated as an expression by combining several variables and constants. But whatever is on the right side of equal sign got to be assigned to a variable. So if we've got a variable called AB, then we're fine. Okay, let's print AB, and this is perfectly fine. We're assigning 7 to a variable named AB. Okay, and we're printing it out, but we cannot assign to a sum. This is not system of equation. This is equal sign in Python means take whatever's on the right side, stick it into whatever's variable on the left side. So it implies on the left side of equation equal sign, there's got to be always a variable there. So this is not valid. We're getting syntax error. Okay. So that's what I've got here, pre-made here. And we've already seen in many cases that we can reuse the same variable over and over again to put different values there. A common case is, so here let's get two assignments. In first line we're putting 1 into C, we're printing value of the C. Now we're putting 2 into variable called C, we're printing it out. So there's nothing strange here. This is perfectly fine. The very common case is using the same variable on both sides of equal sign. The way it's interpreted by Python, let's make C here. First one is that we're in the first line, we're putting 1 into variable named C, and then in a second line, we're taking whatever is in C, which is at this moment 1, we're adding 1 to it, so the result is 2, and then this 2 goes into C. So now I'm expecting that when I'm printing C, I should see 2. Well, that's the case. Yeah. So I first assigned 1 to a variable named C. Then I calculated an expression that adds 1 to whatever is in C, which is 1. So the result is 2. It goes into C, and now I'm printing C. So now I'm getting 2. So this is very common, pattern of very commonly encountered thing in programs. Once more, it is not an equation. This is an assignment. This is something which takes the right side, evaluates the values, takes the values of the variables, evaluates the expression, puts it into the variable with the name on the left side. Yes, to a certain extent, there is a way to auto increment, but this thing is not gonna work because this is not there. What you can do is you can do something like this. So what a statement like this means is so C plus equals 1. This is equivalent to C equals C plus 1. So this is a shortcut for a statement like that. But in several languages, there's one shortcut further where C plus plus means C equals C plus C equals C plus 1, but this thing doesn't exist in Python. So you've got to use the variant here. Obviously, you can have C, you can increment by 3 or whatever the number goes here. So let's do C and let's print C. So here we already went up to 5. So we had 1, here we had 2, now we added 3, so we should have 5, and that's what we've got here. So this is a shortcut for C plus 3. There's no special case for 1. This thing also works with minus, if as far as I does it. C minus 3. Yeah, it also works with minus, so you can decrement by whatever's on the right side. So this is more. It makes code a little bit shorter. Okay, so now there are cases where we want to convert between different data types. So let's say we read a text file, we end up with numbers written as a series of digits as text, and we want to convert this text into a number. To do this thing, we can use something called a casting or a coercion function. By the way, functions are things that look like our print statement. It's a name of a function with one or more arguments that follows in a round brackets. Print is an example of a function. It's essentially a pre-written piece of code hidden somewhere inside the Python interpreter, which is used every time one uses a print statement to call a print function. So another let's see, how did I have it? Yeah, we also had a type function. I used before a type C to get information about type of the C variable. I can run it, and I'm getting integer as a result. So the type function takes an argument and returns the type of the variable. We can print, so we can nest the function calls. We can first call a type function and pass C variable as an argument, and then the result of this type C is gonna be printed out. So this is how a line like this is interpreted. Okay. Another functions that you might find useful is a function that finds the maximum of several numbers. In this case, we can have as many arguments as we want, and the function is going to return the largest of those. So let's see if that's the case. Yep. Here's another case with where we're finding the smallest of the numbers passed as arguments. So now we're gonna get minus 5 as the result. Obviously, we can, instead of using a statement to be printed out as the last one, we can print the result, or we can store the result of a function call mymin in a variable mymin. We can now store the result of a function called in a variable, and now we can print mymin. So here's the result. The point is that function code returns a piece of data that can be either printed or stored in another variable and then used later on. So that's what functions do. We can, out of curiosity, try to see if print function is returning something other than just spitting out something on a screen. So let's see what happens if we do print mymin print. So here what we're trying to do is we're calling a print function on mymin. So this is gonna print out as before -5. But I'm just curious, if there's any value that print mymin is returning. So I'm trying to print out whatever the nested print does, and let's see what happens here. Well, there's nothing. So it turns out that there are functions that return no value. It might happen if that's the intention of whoever wrote the piece of code. So here we've got a function that is used only to print things on a screen, but it does not return a value. So this is perfectly fine. It does happen. So maximum and max and min are functions that return the value. Print is a function that does not return a value. Okay, another math function is absolute value. This is just as in math. You're losing the minus sign if there's one. So those are the basic examples of functions that operate on numbers. Going back to conversions, let's the type. Okay, so we already went through the types before. Okay, so we're fine here. Okay, here's what I'm looking for. So let's start with my number set to 123, and now we're gonna print our number, and we're gonna print the type of our number. Okay, so we printed out 123 as a number, and this is 123, and the type of our number is integer. That's fine. Okay, but what if we do have as our number a string with composed of characters 1, 2, and 3? Well, if we run this program, we're gonna get 1, 2, 3 as output from the printing my number. There's no difference. There are still 3 characters, but now the type is string. Okay, this is a problem, because if we try to perform operations on strings, they will not behave as numbers. So if we want to use 123 as a number, we've got to make a conversion. We've got to convert a string with the digits 1, 2, 3 into a number. To do this thing, you can coerce a string into a number, or cast. That's another term. To do it, we just type str. This is a function that does the conversion, and then int if we want a number. So this is a function that converts a string among others into a number. So now if we do int 1, 2, 3, and we want to get the type of it, type, okay, and we want and see what happens. Well, so now our we are getting output from print as before, 123 as a string. So my number is a string that we set one line above here. But now in next statement, we're taking a string called one with composed of 3 characters, 1, 2, 3, and we're converting it into integer. Conversion worked. The type is telling us we've got integer here. We can also print it, and the type as returned by the print statement is integer. If we wish, we can make 1, 2, 3 into a floating point number by saying float. Okay. And now, now the type is floating point. We can, let's see, we can instead of converting constants, instead of converting fixed string, we can pass my number. Okay, so my number is initially a string composed of 3 characters. Now we're converting it to a floating point, and we can run it, and conversion still works. No errors here. The print statement returned information that we're dealing with a floating point number. The difference will pop up when we try to print those things. So let's try to print my number. Okay. And now my number after converting it into a floating point. So now what happens is we got a syntax error. This is once more too many brackets here. So I've got to get rid of unmatched bracket and put a couple of spaces to make it look nicer. And now if we run it, we're getting my number printed as 1, 2, 3. This is exactly what was set a couple of lines above. But now when we print a floating point generated from the 1, 2, 3 string, we gain the decimal point, because now the second argument to the print statement is a floating point number, so it's printed out with 1 decimal, 1 significant digit. So the conversion worked, and we can also convince ourselves that the type is floating point by just printing type float. So here we are missing. So now once more, syntax error. The interpreter tells us something's, there's a problem here. Apparently I'm missing a comma here. So once I add comma, we should be fine. And now we've got my number printed out as 1, 2, 3 because it's a string. Now we've got a floating point number generated from the string. So we've got the decimal point, and it is indeed a floating point number, because if we print type of my number converted by float function, it tells us we've got a floating point number. So far we converted string into integer, we converted string into a floating point. We can do conversion in the opposite direction. We can try to convert the number into a string, str, and let's say 1, 2, 3, and see what happens. Well, you see it's a string. If you notice that there are quotes printed out by the out statement here. So the conversion did happen. If we were to print it though, you wouldn't notice. If we print 1 to 1.23 converted into a string, we wouldn't see the difference, because that's how print statement works. The string is printed out without surrounding quotes, so we can notice it. But if we print type of str 1.23, now the type is gonna be string. So conversion indeed happened. It is worth noticing that conversions will work only if the arguments can be converted. So if we try to make, let's say integer out of I don't know, out of my string. Okay, what happens? Well, this conversion doesn't work because my string is a not proper representation of an integer. This is just a string that doesn't have a numerical value. So conversions are not always safe. If whatever is passed as an argument can't be converted, then program will stop and generate an error. The same thing goes in opposite direction. Well, conversion of okay, let's comment it out. If we go in a opposite direction, we can do something like string 1, 2, 3, E4. This is gonna be perfectly fine. So conversions from a number to a string will work all the time, as long as the number is there, either as a constant or a variable. Conversion will work, but going in opposite direction might not work if the string can't be converted in a proper way into a number. So this is a case where, depending on the value passed to a function might generate a proper result or might generate an error. So this is something to be something to pay attention to. And then we've got more conversion types. In general, it should work as long as the argument passed can be converted in a sensible way. So here's more examples that I'll skip through. Okay, so those are the basic operations on variables. This is how things can be, how variables can be set to a value, and then how they can be combined to calculate some other value based on some math operations. In many cases, we want a program decide what to do depending on what relationship between the values stored in different variables. To do this thing we've got to be able to compare variables or variable against a constant, and that's where logical comparisons and logical operations come into play. The simplest thing to check is to ask if two numbers or two variables are identical. So we can check if 2 is equal to 2. Okay, note that here we've got the equal sign repeated twice. This means compare what's on the left with what's on the right, and then return true if the values are identical or false otherwise. So 2 equals 2 will likely return true because 2 and 2 are identical. We can use, instead of fixed values, we can use A equals 2 and B equals 2 and compare A with B. Okay, and here the value of A is 2, the value of B is 2. So our comparison evaluates to true. If the numbers are different, we're gonna get false. Obviously, we can store the result in a variable if we want. So we can have a variable, let's say, is equal. So here we've got a variable called is equal, which we set to the result of comparison, and then we can print it if we wish. Copy and here. So now if we print, we're getting false. We're getting false because we assign the value of comparison between A and B to is equal. A is 2, B is 3, so is equal is false. This is what we've got here. If we have A and B identical, then our print statement will return true. So instead of having just as we had before fixed value or a variable, we can have an expression. So we can have, for example, check if A is twice as large as B by putting on the right side an expression, okay, and then if we run it as now, we're getting false. But if A is 6, now A is gonna be 6, 2 times B is gonna be 6, so we're comparing 6 with 6. Those two things are equal, so then is equal is gonna be set to true, and that's the case. And it's perfectly fine to put expression on the left side of a comparison. This is different than assignment. With assignment, what's on the left side, there's always a single variable name, nothing else. But when we're comparing things, we can compare two expressions, the values of two expressions. So the comparison like here, it's perfectly fine. This one is gonna generate false. Apart for comparing two things to check if they are equal, we can check if they are not equal. The not equal comparison looks like exclamation mark and equal sign following it. So here we're checking if A is different than 2. Okay. And yes, it is, because it was at this moment 6. Okay, we can always check the current state of the variables in a variable explorer. So that's so that's why the variable explorer is convenient. We can look up the values if we need somewhere in the middle of playing with the code. Okay, so we had checking if two things are equal. We had checking if two things are not equal or different. We can check if two variables are great, if one variable is greater than the other one. So here's another case. I'll uncomment here our and I'll print this thing, and here's the result. A is not greater than 5. 2 is 2 is smaller than 5, so result is false. We can use as before. We can use either fixed numbers, fixed values, or expressions or variables. So equivalent version using variables is here. I'm just setting A to 2, B to 5, and then I'm checking if A is greater than B. No, it's not. And this is first false is coming from the statement here, and second false is coming from the print statement here. Okay, obviously we can use less than or less or equal or greater than equal. So there are 4 different versions of less or of comparing the values in this way. So here it once more another case of a comparison. Okay, so with numbers, and all this time I was working with numbers. So far I was comparing variables or results of expressions that were evaluated to a number, and I was checking if the numbers are exactly the same, or one is greater than the other, so or one is different than the other. Comparisons do work with other data types. We can check what happens when we try to compare strings. Okay, let's try to see who's bigger, cat or mouse. And apparently cat is not greater than mouse, as our print statement is letting us know. We can try to make mouse bigger by using capital M, and where is it? Cat, where I'm missing. Why do I want to come? Yeah, and now I made mouse actually smaller than cat to make it more entertaining. We can combine all of this thing in one run to make it more entertaining. Okay, we can run, and we can, let's say, we can, okay, so, okay, and we can print it like this. Okay, cat and mouse. Okay. Here. Okay, so let's print those 2 things. Apparently, lowercase non-capitalized cat is smaller than mouse, okay, but non-capitalized cat is greater than capitalized mouse, so this sort of looks funny, but we can actually go through and look at different cases and see what happens. The most likely case is that the strings are ordered by alphabetically. To convince ourselves that's the case, we can start trying different cases. So we can first check what's the relationship between A and B. Okay, and let's try this. So A is smaller than B, apparently. Here, yep. So that's, I'm gonna get rid of this because it's annoying. Okay. So A is smaller than B. Now B is presumably going to be smaller than Z. So That's the ordering of lowercase characters. Now, what about capitalized characters? Let's say A is less than B. Well, that's still true. Okay, we are fine. So capitals are ordered in the same way. What about capital A and lowercase a? Well, if we try those two letters, now we've got false, so it means that actually capital A is smaller than capital lowercase a. Yes, that's the case. So it looks like the letters are ordered as A, B, C, and so forth. Then we've got A and B and C and so forth. So far that what came up with from playing here. And now what about digits? Well, we can try, we can keep going. We can try compare 1 to A, let's say, and see what happens. Well, 1 is smaller than capital A, so it means digits will precede capitals. Okay. As you notice, I've got a series of statements here without print, so none of them but the last one is printed. So that's the usefulness of the approach I'm using. I can print out just the last statement here, and the things above are just there for reference. I don't have to remember what I use. So okay, so if this is the case, we've got digits presumably before the capital letters. How are they ordered? Well, 1 is presumably less than 2. Yes, it is. What about 0? Well, 0 is not, so the numbers will be ordered 0, 1, 2, and then we're gonna have A and Z, and then we're gonna have A and Z, and so forth. So that's how strings with the single characters are ordered. This is just alphabetical order. The only thing we got to remember is the digits are preceding letters and capitals are preceding lowercase characters. So that's how single character strings are ordered. If strings are longer, then let's print this one for a change and comment everything else. And if we print the comparison here, the order is essentially alphabetical, the same way as in a dictionary. Whatever follows the first character doesn't influence the order. But if the first character is identical, then the order will be determined by the next character. So this is exactly like in dictionary. We've got to remember though that the capitalization matters. So if we put capital B here, now the order is gonna be reversed because the capital B actually precedes the lowercase a. So that's how ordering of the characters goes. With other types of with other types of variables, other data types, the ordering rules might be different. The most commonly used are the ordering of the numbers. This is exactly like in math, and ordering of strings, and this is how it goes. It's essentially alphabetical with few exceptions. In case of strings, the way it works is every character do have a number associated with it, and internally Python is converting the first characters to numbers, compares the numbers, and then if they are different, then it can decide who's bigger, who's smaller. If they're identical, then it takes the next character, next pair of characters, and compares those. To get the numbers that are used, you can use a function called ORD, it goes for order, and it's gonna return you a number. For capital A happens to be 65, for lowercase happens to be 97. Actual numbers don't, the values don't matter, but they are the numbers used for ordering characters. Technically, what those numbers are so-called ASCII codes. So that's how characters are ordered. Okay, what else we can do with strings other than comparing them? Well, we can check if a string starts in a specific way. We can check if a certain character or a series of characters shows up in a string. We can, for example, check if, let's say, capital AT is in a cat string. Well, it is not. There's AT in cat, but it's lowercase. So if we switch to AT, we're gonna get true. So this confirms that AT is somewhere inside the cat. Okay. If we want to check if AT is missing from cat, we can use the not in to compare for the check, and we're gonna get false because AT is present in cat, so not in is gonna return the opposite, so it's gonna return false. Okay, this is equivalent of saying not in cat. So here's a case where we've got a test for AT present in cat, and then we're inverting the result by applying a not function or not operator. So here the result is fine. In general, comparisons can be combined together, so we can using logical operations. So we can AT is, can check if AT is in cat, and let's see CA in cat. So we can combine logical comparisons using logical operations. So we can check if both AT and CA are present in a cat. Yes, it's true. Obviously, my string cat, we can use, instead of hardwired value, we can do my str and my str and we can check if both AT and CA, if both AT and CA are present in the string we passed as one of the arguments to the in comparison. We can also use an OR operator. So AND is gonna check if both comparisons return true. We can use OR operation to check if at least one of those two comparisons are returning true. So if we do something like that, the right comparison is gonna return false because there's no capital CA in cat, and then the first one is gonna return true. So if we run our snippet, now we're gonna get true because the left side evaluates to true and OR is true if one or the other is true. So here's the example of combining comparisons by using AND OR operations. We also had the example of NOT used either as a part of comparison or NOT can be applied outside here. So then this is gonna get us inverse of the OR test. As with math operations, the conventional rules of precedence for logical operations apply. If in doubt, you can always put round brackets to enforce the order that's intended. So here's example with comparisons using numbers. So here's yet another case. We're testing if P is greater or equal 0 and smaller than 1, and it's not the case because it's bigger than 1. So we're getting false as a result. Here's another AND. Here's logical OR. Here's another case. I did it on AT and cat. Here's something more biologically relevant. There's a sequence of some piece of a DNA sequence, and I'm checking if there's one of the stop codons present there. So I'm printing out. I'm assigning the string I'm interested in to my sequence variable, and then I'm printing the result of a test, which is first checking if TAA is present in my sequence, then it's checking if TGA is present, then it's checking if TAG is present. And if any one of those is true, then I'm gonna get a true as a result. In this case, yes, I do, because there is TGA, there's a TGA here. So the result is true if TGA is not there, because there is let's say CA. Now I'm still getting true because now I've got TAA, let's see, TAA, no, TGA, no, TA, why is it? Let's see. That's true. Well, TAA, no. TGA is still here, so I still do have TGA here. If I change it here out, now false is gone. So here's another example of combining comparison. We already went through NOT to negate the result of a comparison. So far, whatever I was doing, I was printing the result of comparisons. But in general, the most common case is to use the result of comparisons in so-called conditional statements. They allow one to write a program that behaves in a different way depending what data you feed it with. The most common case of a conditional statement is if else, or not most common, the simplest one. The way it looks like is it starts with if, then there's a comparison. I'll do, where I am. I'm gonna go here. I'm gonna set A to 5, B to 0, and now the conditional statement starts with if, and then there's a comparison, something that returns, expression that returns a Boolean value, logical value. So let's say if A is greater than B, and then there's a colon, okay? So here in this line, we're checking who's bigger, A or B. And now, if the condition evaluates to true, block indented just following the if statement is gonna be executed. So we can, let's say print A greater than B. Okay. If condition is not fulfilled, then the indented block is gonna be ignored. So let's see what happens. So if we run our snippet now, we do have the output output of the print statement coming out here. If B is greater than A, then if condition is going to evaluate to false, and the print statement is not evaluated, not executed. There might be one or more entire block of statements following if will be executed. If we want to do something, if condition is false, then we can add else, once more flush with the initial if statement, and then indented block is gonna be executed if the condition is false. So here we can do print A is less or equal than B. Okay, so now depending on what's the relationship between A and B, we're gonna print out either the block following if or the block following else. So we can run it now. So here we're learning that A was smaller or equal than B. If we go back to original 5 and 0, we're printing out the block following if. Whatever follows if and else can be one or more statements. So we can let's say print A and B, for example, here, and then if we run our cell, we're gonna get the values of A and B printed following by A and B. In print int, can you do I still 5-0? Let's see. Print A. You should be getting, I think B should be printed as, let's see, do print int A. Well, let's see, print int A like this. Well, int a, yeah, well, if you, well, if let's do this, let's see what happens. Yeah, it still works. Apparently, the conversion is working. What happens if we make 5-1? It's still, so apparently int is truncating the decimal points. So so even doubt try. Apparently int function is coercing a number that's a floating point into integer by truncating, by getting rid of a decimal point. So the interesting thing would be to check what's with the negative value and what we're gonna get. We're gonna get, but we've got to have -6, let's say. So it's also, so int is gonna dispose of the decimal point also for the negative number. So there might be a different variant of a function that's actually taking the greatest, the largest integer, not greater than an argument. So there might be different functions there. I don't know this thing by heart. So as you can apparently see, integer int can convert from a floating point into integer. So we can go the other way around. We can do float, and we can now convert b, which is initially integer. We can print it. We can convert it into a floating point. So conversions between integers and floating points can be done by using the casting operation. So that's what's going on. But the point about the conditional statement is that for the if else construct, we do have an if conditional statement indented block that's executed if condition is true, and then optional else, and the indented block that's executed if condition is false. Once we're done with the conditional parts of the code, then print whatever follows at the same position as initial original if and else is gonna be printed no matter what. So irrespective of what are the which block is executed based on the values of a and b, the next unindented statement is gonna be executed all the time. Thing to remember is that if there's additional indentation somewhere there that shouldn't be there because it's not in a conditional statement, this will generate an error message. So if we try to do it like this, we're gonna get indentation error. So indentations are allowed only in some in special cases. Normally, if there's a series of statements to be executed one after another, they should be all indented to the same depth, either flush to the left if this is main series of statements, or they should be at the same indentation depth if inside of conditional. So the mismatch of indentation inside if statement also will generate an error. It's gonna be another case of indentation error. This is because those two things are different depth. They've got to be matched in terms of how far to the right you go. The nice thing about the editor in Spider is that if you press enter it will try to guess what's the proper indentation depth, and if you use tab, it's gonna get things flashed. So the editor is trying to help you to write things that's formatted in a proper way. So here was a simple example of a conditional statement. Here's another one, which is exactly the one that I actually played with before. Obviously, if you want to compare two numbers, you don't have to write your own if else statement. You can just use max a b, which I introduced just a while before. This is exactly what's sitting inside max function. There's gonna be some variant of a conditional statement, except that it will allow for multiple arguments to be passed to a function. So sometimes there's already pre-made function that does whatever you want to achieve. Okay, so in the case here, we're comparing just two numbers, and we're checking if one is either greater than the other or not. So those are only two possibilities we're checking. In general, there might be more cases that we want to look for. For example, we might want to check if two numbers, as here, are either one is greater than the other. Okay, so this is if A is greater than B, then just print that A is greater than B. But we might want to check if the opposite is the case, if B is greater than A, okay, or A is lesser than B. To do this thing is we can have a series of conditionals, but apart from the first one that use if, all the consecutive ones are using if. This is abbreviation of else if. So if A is greater than B, run the indented block and terminate execution of the conditional. But if this condition is false, then go to the next one, check if A now is less than B, and if it is, then print whatever is in a indented block following the condition that's true. Okay, if this one is not true, then we can use else to catch the remaining case, which is gonna be that A is exactly equal to 2. So here we've got a conditional statement that's more complicated. We are now checking three different possibilities. We're checking if A is greater than B, if A is less than B, and then the last case is that A is equal to B. Does it work? Well, if A is 5 and B is 7, A is less than B. If we flip them and we make B A greater than B, that's what our conditional says. If they are exactly the same, the first conditional is evaluated to false because A is not bigger than B. The next conditional that's checked is if A is less than B. No, it's not. So this one is also skipped. We're left with else, and now else is printing out whatever you see here. Obviously, if there's more cases to test, we can always add another elif. A is greater than 2 times B, for example, and we can print something else here. So in principle, there might be several elif statements if there's more cases to check for. So so those are the two versions of conditionals. Here's another example. I'm just trying to calculate inverse of f and strip it of the sign. So here's another case, and I've got to pay attention to f equals 0 because then I can't calculate 1 over. So I'm just printing out that the f is invalid. I can't invert. So here's another case of conditional. So that's the most common case where the comparisons are used and Boolean expressions are used. In many cases, we don't store the values of comparisons as Boolean variables. In most commonly, they are used somewhere inside if statements to check if condition is true or not, and then the program can decide what to do. So we are getting there. Okay, just to recapitulate, we introduced several data types: Booleans, integers, floating point strings. We introduced a bunch of operations that we can perform on those. We can do regular math on the numbers. We can check if a given substring is present in a string. We can check if one string is preceding another one by alphabetical order. We can compare the numbers if they are greater than or equal or whatever. We can use the results of those comparisons inside conditional statements to make program behave in a different way depending on the result of a comparison. So that's how far we did get so far. Going back to strings, there are a few more things to learn about text and strings in general. One thing is how to define it. We covered most of it. It's the simplest cases. We can use either single quotes or double quotes to define a string. So far I was using double quotes most of the time. Single quotes are fine. It's different. There's a difference between single quotes and double quotes in some languages. In C++, there's a different meaning for those. In Python, single and double quotes are interchangeable. It is convenient because it allows us to define strings that do contain either single and double quotes. So let's say here we've got ABC as a simple string ABC. That's fine. The value that my string contains after the assignment is just 3 characters, A, B, and C. Same thing with double quotes. So here's the single quotes, here's the double quotes. Now, if we want to put double quotes inside a string, you've got to make sure that we define a string using the other type of quote. So for AB double quote C, the way to define it is to use single quotes to mark the beginning and end of the string we're defining, and then double quote can go inside. So this one is fine. We've got A, B, C, double quote, and C as our string. If we were to use double quotes to open it, this would make this would make Python quite confused, because it would see the initial AB string and then C and single, and then it's a syntax error. This is not valid because it's not clear where the string is supposed to be ending. So that's why we use the alternate version of a quote to introduce the other one inside. And we can do the reverse. We can use double quotes to open and close string, and then single quote can go inside, and we're fine. Now we've got A, B, single quote, and C. So that's why there are two ways to define a string. It makes the other quote character easy to insert. Another option to put a character with a meaning inside a string is to use so-called escape character, which is a backslash. Character with a meaning, I mean, what I'm trying to say is that when the Python is reading a statement like that, it knows that double quote has a meaning. It means start definition of a string. And then once the string is entered, the next occurrence of double quote means, oh, that's the end of the string. So those occurrences of double quotes do have a meaning. If we were to put a double quote inside, this double quote here should be stripped of the meaning. It should be stripped of, oh, I'm marking the end of a string. To strip this meaning, we use an escape character called backslash, which is a backslash. If we put backslash here, now we're fine. Now we've got a string. Python knows it's a string because we're supposed to start the definition of a string by encountering double quote. Now we've got a bunch of characters. Now we've got the escaped double quote. Okay, so this is a regular double quote. It's not a double quote meaning end of the string. And then we've got finally the double quote that terminates the string. So now this one is perfectly fine. And we've got the double quote sitting here. And if we can do it the same way here, we can have single quotes here. So now this is gonna generate syntax error because we've got start the string, well, we've got A, B, end the string, and now there's the spurious C showing up here. So this is not okay. We've got an error. And if you look carefully at what the editor is showing us, is you notice that the C is in a different shade than the rest of the string. So the editor is actually trying to tell us that something's wrong here. To fix the problem, we can now escape single quote here, and now we're gonna be fine, and we're gonna get A, B, apostrophe, and C here. Now, the drawback is that the backslash on its own is not gonna register. Oh no, it will. Actually, backslash is fine. So backslash that is not followed by a special character, by a character with a meaning, will be fine. But if we try to have a backslash and single quote now, something like this, here, a string defined like here, where we've got single quote starting a string. Now we've got A, B, now we've got escaped single quote and then C. So that's fine. It's gonna show up here. But what if I want to have a string that looks like A, B, backslash, single quote, and C? What if this is what I want? I want to have a backslash followed by a single. Well, we can escape backslash. We can just put backslash. This one is gonna escape a character with a meaning, which is our backslash here. So now if we print it, is it gonna work? No, it still doesn't work. Okay, so we can't do it. Well, if that's if this is not working, then operations are to rescue. What we can do is we can just put the string together from fragments. We can say AB plus backslash like this, plus backslash, yeah, like this, plus C. Let's see, does it work? Yep. Well, except that I want, how do I get down backslash? Yeah. Let's see, AB, let's see, AB backslash. There, well, exercise for the evening, try to print out AB backslash apostrophe C. So, I mean, if you keep playing with this thing, you'll find a way. There's got to be a way to put a string like this together. But the general idea is that that backslash character is used to cancel the meaning of the following character. So so sometimes those things might be kind of hard to get. The only way to do this thing is to play. Okay, going back to strings. We already checked in or not in, so we already went for testing if something is present in a string. One more thing. We can, as you can see here in here, we can put together strings by just adding, adding characters. So this is gonna concatenate 3 pieces into one string here. Okay, we can also multiply string by a number. Okay, is, let's say, ATG times, we can multiply string by a number and print, and we're gonna end up with 5 copies of the string that was multiplied. To make it clear, I'm gonna put a space. So this corresponds to making 5 copies of ATG space and then concatenating them then together. And here's what we've got here. So there are 2 more ways of making strings that are made either from smaller pieces or are made by multiplying, by repeating a certain motif over and over again. So those are 2 ways. Obviously 5 might be a variable, so times rep. So we can say something like rep equals 6, and now we should most likely get 6 copies of ATG with spaces in between. So we can vary the length of the string by changing the number of repeats of original motif. So here's another way of making strings. Okay, here is our in and not in that we went through. Here's something more biologically relevant. Here's another case of concatenating things I just went through before. Here's multiplication. Obviously, the addition and multiplication can be a concatenation, and then multiplication operation can be combined together. So here's example where this expression evaluates to 10 copies of lowercase abc followed by def. So that's what we've got here. So wherever a value can go, like in a print statement, as long as there's a valid expression, we can use it. So that's how strings are made. Apart from testing if a given motif is present in a string, we can check more strictly if a string starts with a certain character or a group of characters. Here's the case where I've got a string ABC and I'm checking if it starts with B. Presumably not. Okay, but if I check if it starts, if our ABC DEF, let's say, starts with AB, yes, it does. So here's the case where I can check how the string starts. Okay, if we're interested where the substring is within our string, we can use a find method. By the way, this is a case of so-called method. We've seen so far functions. So far we've seen code that look like print and argument of some sort. So the way it works is we had a function that takes a variable or a constant as an argument and does something to it. In many cases, for many data types, there's a set of functions that are used just for those data types. Then the way to call functions like that is using a syntax like this. We've got some sort of argument, let's say some sort of a variable, and then dot, and then the name of a method. So this is what happens here. We've got starts with AB. Let's say AB and arg equals ABCDE. Something like that. So here we've got a variable arg that happens to be a string, and now for the string variables there's a method called starts with that is called on our variable of a string type, and it's passed an argument that happens to be the substring that we're looking for to start the string. So that's how this print statement works. You can there's no arg because I've got where is it? Print arg. Oh yeah, this one is wrong. So here we've got a string ABCD whatever. We're calling a method called starts with, and we're passing AB as an argument. You can think about those as a shortcut for saying start with arg AB. Those two things are essentially identical. It's just that some of the functions are written in such a way that they can be called only like this. But otherwise it's the same. It's as though this starts with function is getting this extra argument that is the variable name in front of it. So so the method we've got here is checking if the string here starts with AB. This tells us only if AB is at the very beginning, doesn't tell us, it won't find AB in any other place. In will find that AB is present or absent, but it's not going to tell us at what position. To check what's the position, we can use a find method. Okay, so let's get arg A, B, C, D, E, F here, and then we can check arg find, let's say C. So let's try to find if there's a C character inside our, or let's say my string here, and let's do it here, my str. So let's check if C is present somewhere inside my string. And if we run it, we're getting as an output 2. This is the position of the C character inside of my string. The only thing to pay attention to is that we're starting counting from 0. So A is gonna be at the 0th position, B is in first position, C is in the second. That's why we see 2 here. We can ask for a longer things than the single character. We can look for C, D, E. Okay. And once more, the position is gonna be 2 because the first character of our substring we're looking for is at position 2 inside the string that we're checking for. So this is a way to tell to find what's the position of the substring. If there's no match, if we've got something that doesn't occur in my string, then the result is gonna be negative. So this is a simple way of this helps to set up an eval statement to check if a given character is or given substring is present in a string or not, and we can have conditional to check that and then print out the position if thing is present, for example. So this is a way to find if substring is present. So this is finding things in strings. We can change strings to either uppercase or to lowercase if needed. Okay. We can also count how many times a given substring shows up in a string. Here's the example where we're counting occurrences of AB substring. There should be 1 and 2, and we do have indeed 2 occurrences here. Okay, and that's the very last thing one more thing. We can also check how long the string is, and for that there's a function called len. The thing to remember is that len is a function. In contrast to count and upper and lower and many of the methods that you've seen for the strings, checking the length of the string is actually a function. So we don't say my string len. We don't do this. This is not valid. To check for the length of a string, we've got to call a function and pass the string as an argument. And now this one is gonna tell us that the string is 10 characters long. We can check here 1, 2, 3, 4, 5, 6, 7. We've got 10 characters. So that's what the length is returning. So this covers, I think, basic operations on strings without going after individual characters and things that are more complicated. We're gonna go through more details of dealing with strings tomorrow. There's something about internal structure of how Python works that makes it more convenient to have len defined as a function, not as a method. It turns out that it works a little bit faster when len is defined as a function. So there's a reason there. It was actually decision made by the designers of Python. So there's a reason behind it. So for end users, it's something that you've got to remember, that len is always a function. Okay, so now talking about functions. So far we were using functions that were already built into Python. Obviously we can write functions on our own. Okay, here's a simple example. This is a generic structure of a function, how a definition of a function looks like. It starts as we go on the fly. Let's make ourselves a couple of numbers here. It starts with the def, and then the name of a function, and then a list of arguments. It could be nothing there. It could be 1, 2, or more. Okay. In most common case is that we've got a discrete fixed number of arguments, let's say a and b, like here. And I'm trying to define a function that is gonna return true if a is, that's gonna return the bigger of the two numbers. Okay. So the body of the function, the code that's going to be executed when the function is called, is going to be indented. So that's another case where indentation matters. So now I'm going to check if a is greater than b, and then if that's the case, I want to print it. I want to print a. Otherwise, I want to print b. So that's my my function definition, and that's all. This is a function that doesn't return a value, so I don't have a optional return statement which would go here, return something. Okay. Return, let's say, return, I don't know, a greater than b, for example, something like that. This would be perfectly valid, but I don't need it, so I'm gonna have a function that just prints two things. So this is our function definition. Once the function is defined, we can call it. We can call our function on with two arguments, 5 and 7, and see what happens. Well, we're printing the greater of the 5 and 7. So that's what we've got here. If we flip the order of 5, 7, and 5, we're still getting 7 because my max is gonna print out the bigger of the two values. Thing to remember is that the A and the B variables used as arguments in a function are not related to variables that are existing before the function definition. This A and B has nothing to do with A and B defined before the definition. So if we now print A and B after the function is called, the values are gonna stay as they were before. We're still printing 7755 because A is 77, B is 55. Inside definition, this A is separate from anything else defined outside. It doesn't work the other way. If we've got another number called C here with, well, let's say 33, if we can use it inside our function, and let's see what happens. We can print C, and let's see what happens. I'm gonna get rid of this. So now I'm printing C from inside our function definition. And apparently inside the function, C is visible. So things from outside are visible inside the function definition, provided they are defined before the definition, before the function is called. But whatever's used inside the function is not, function definition is not visible outside. So you don't need curly brackets. Curly brackets are gone in Python. Some people love it, some people hate it. The indentation plays a role of brackets. So as you notice, I've got inside definition, everything inside definition is indented one level, and then if there are statements inside that require indentation, then they've got to be indented relative to wherever they start from. So the print statement here is indented one level in. There's no brackets there. So in C, definition would look like this, right? You would have a curly brackets here, and you would have something like that. So this would be C, more or less. In Python, it's not there. Its syntax is slightly different. But the meaning of the code is essentially the same. Okay, so we made it to the function definitions. For your entertainment, try to write the function of the day. This is something very simple, which essentially recapitulates what I mentioned before. It's a function that's supposed to find out if in a given sequence there's one of the stop codons. So let's assume that you've got my sequence with a piece of DNAs ATG, CAT, AGT, 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 A, GCC, AG. So let's assume you've got a variable with a DNA sequence there, and you want to have a function that let's say a function that's going, you'd call like has stop. Let's see. Has stop. Okay, and it takes my okay. Let's do it this way. So let's say we want a function that will take our sequence as an argument, and then it would return either stop codon, present, at position, whatever. If there is stop codon there, if there's no stop codons in a function, then in a sequence that it should print out stop codon not present. So the function would start like def. Well, it's got def has stop something like this, and now there should be a body of function that will do whatever description says, and then the call should be somewhere here. So here's a simple function to write to practice whatever you've seen so far. So I think that's it for today. Are there any? No. Oh yeah, Daniel is saying that if there's more than one definition, then you've got exactly like Daniel's is writing. You've got series of defs, essentially def f2, and so forth. So def. The thing to remember is though that you've got to first define a function and then only then use it. So if I were to call mymax here, this is not gonna work, because well, not if b, if a greater than b, this will not work. I've got to clean the remove variables, though. This will not work. Interestingly enough, when you run it for the second time, it's still not working. So that's fine. So the function calls must follow the function definition. So function definitions got to be first, got to be at the top of your code, and then you can use it. Okay, I'm gonna post. Okay, so if you want to play with the function, write the code, send me the code by email. I'll comment on this thing if you wish. I'm gonna stop recording now, I think, where I am. Yeah, I'm gonna stop recording now. Do you want to stop?